All right. Let's find some points of intersections and let's just start discussing setting things up. That's all we're going to do. We're going to think about setting things up. I'm not solving any of these ending ones, but we're going to start with a point of intersection, and then we're going to talk about how we would possibly find some areas. Okay. So first off, we're going to say find the points of intersections of the circle r equals 3 cosine of theta and the cardioid r equals 1 plus cosine of theta, which I sure as heck hope you know what 1 plus cosine of theta looks like now. So I want to actually just kind of sketch a graph first. Okay, there we go. And I'm going to write in my 0 pi over 2 pi and 3 pi over 2. Come back around in the circle. Come back to 2 pi. Cool. Do you remember doing these from the last section? That's a circle. Symmetric about x because you got cosine. What's the diameter of that circle? It's 3. So I'm going to draw that one in blue. So it's a circle-like thing. That's supposed to be a circle. You believe me? And this goes out to 3, 0. So if you caught those little patterns I showed you before, this will make life a little bit easier. So there's our circle. 3 cosines of thetas. Neat. Now let's do our 1 plus cosine of theta. We know where that is, right? That's going to be at 2. And it comes through and hits somewhere. Does something like this. Goes through at 2, 0. Cool. So we want to find our points of intersection. Well, I mean, you can look and be like, bro, we're going to have some points of intersection. We're going to look a little something like that. I know they're there. But how do we find points of intersection? That's right. You just set them equal to each other. So we just take 3 cosine of theta. Right? If r is equal to both of them, we're trying to figure out where it's the same gosh darn thing. And we set it equal to 1 plus cosine of theta. So, I don't know, let's subtract over that cosine. You know, you got 3 of them, minus 1 of them, leaves you with 2 of them. We divide out that 2, we find out cosine of theta is equal to 1/2, and then we're like, oh, bro, I know this one. It's pi over 3 and 5 pi over 3. We got it. But, what about that little point? What happened? What happened? Wait. So we hold on. So we got our pi over 3 here, right? That angle that goes through, and we got our 5 pi over 3. How it goes through here. But what about this point? What about at pi? I know it hits at pi. I can see it. I know it goes through. So how do we know? Well, it doesn't actually follow through with the equation of a circle. Algebraically, you can't find it. Those coordinates do not satisfy the equation of a circle. So how do we find it? How do we know what it is? And I wish I had a great answer for you. It's knowing how to graph it. And pi. This one, by inspection. By knowing how to frickin' graph. Ooh, that's rough. That's not nice. There's a tricky piece. I will do my best to make certain that your work will work out just fine, so you could do everything algebraically. But I wanted you to see one where it's like, well, how do we find that answer? Looking, knowing how to graph. That's tough. That is really tough. Oh, dang. What are those points? And let me write in the points from now on. You know what I mean? Like, what is this point right here? Well, I know it's got a pi over 3 in it, but what's the radius? Well, you got to plug it in. 1 plus cosine of pi over 3. That's 1 plus 1/2. That's equal to x equals, so 3/2, comma, pi over 3. And then this one down here would be 3/2, comma, 5 pi over 3. And then this point over here, well, that would just be 0, comma, pi. Eesh, it's a lot, huh? Now, Now we're going to set something up. I'm going to call this region. Let's call this region, I'm stealing this straight from your book, so if you want a better picture, just look at your book. Let's call this region A. And then let's look at this region here. And let's call this region region B. And one more just for fun. Let's take this region out here, and we'll call this one region C. All right, let's set up the areas. Let's find the area of region A. Let's find the region or the area of region B. So for the area of A, how do we set this one up? Well, we're going from, we start at 0 and we go to pi over 3. But don't we have an inside and an outside function? I believe the outside function to be, so the outside is r is equal to 3 cosine of theta, the circle, and the inside is r is equal to 1 plus cosine of theta, the cardioid. So let's set up our integral. Again, we are not solving. So we're going to say the area is equal to 1/2 the integral, and we're going to go from 0 to pi over 3. We got to take our outside function and square it. We got to subtract out our inside function and square it. Of course, d theta. So our outside is that 3 cosine of theta. And our outside was the 3 cosine of theta, and our inside is our cardioid, our 1 plus cosine of theta. There we go. That's how we would find A. And then you go through, do work, go solve it. The cosine squareds end up becoming just a pain in the butt, as you're going to see over and over and over. And it turns out, if you're curious, the answer is pi over 2 if you wanted to just check your work. Now let's find the, region B, the area of B now, huh? All right. So, region B, where is that? It looks like we start at pi 0 and we go all the way to pi, doesn't it? 0 to pi? But dude, they're going to switch. They're going to switch from an inside to an outside. We're going to have to do some frickin' work, dude. But wait a second. How are we going to find this? Well, I think that, now this is getting kind of gross. I'm going to take some stuff out of there so we can see it. To get the area in here, if we break it down at this point, this is just the cardioid. And then once we get past that pi over 3, it's just going to be the area of the circle. So it actually just breaks it down into 2 different regions. See this? That's just the area of the cardioid, and then it's plus the area of the circle. That's region B. Well, we're going to say that this is equal to, or our area is equal to 1/2. We're going to go to 0 to pi over 3. And remember, that's just the cardioid. So we're going to say 1 plus cosine of theta, all squared. And then we're going to need to add it to the area of that circle. All right, the area of the circle that was right here. But that's just from pi over 3 to pi. And that is just the circle. So 3 cosines of theta. Sorry, I didn't color code on that one. D theta. That's, I forgot my 1/2. There it was. Or I could have used a big old parenthesis the whole way through. Now lastly, that last region we wanted to find. What if we just wanted to find C, just this region right in here? How do we do that? Well, I think this last one's actually the simplest in my opinion. But my opinion doesn't matter. Your opinion is what matters. It looks like we just have an outside and an inside function. You know what I mean? We just have an outside and an inside function. It looks like our outside function is going to be the cardioid, and our inside function is going to be the circle. So we're going to go from pi over 3 to pi to find that area. So outside function is now switched. We have our inside function now being the circle, and our outside being the cardioid. So we set it up. Same sort of game. So we say A is equal to 1/2, but now we're only going from pi over 3 to pi. And our outside function now is our 1 plus cosine, not going to color code, squared d theta minus our inside function, our 3 cosine of theta squared. Oops, why did I write my d theta there? Gosh. Not starting this thing over. I am not starting this over. D theta, it just takes one freaking integral on this one. We didn't need to break it up into 2. Do you remember the struggles of trying to get this? The area between curves at first when we were doing it algebraically and not with polar? Yeah, it took a little while. It takes a second. This is not simple. I remember the struggles of like, which one's inside? Which one's outside? I don't know how to graph these damn things. Yeah, well, if you're going to Calc 3, this is going to be a big part of your life, except everything's going to be in 3-dimensional. Not just solving for 2 things, but possibly 3 things. Ooh, it's going to be a lot. But if we get good with this, it should be a little bit simpler for our next. So last thing we got to do some lengths of curves. Once we're done with that, we are done with chapter 12. I'll see you in your last video.